these chair slides are pretty short. That's the note well. Y'all have seen that, and we can move forward. That should be fairly straightforward. The blue sheets, it's in the Etherpad. The Etherpad link, the correct one's in these slides. It's also in the agenda. We can do the next slide. We have a very short agenda. Mostly there's some quick updates on the documents, some current working group business, and a new document coming through. So next slide, Eric. On the document updates, let's go to one more slide. 7626 biz, both these and the BCP have both sort of been a little slow moving forward, but mostly that's because primary office there has been tied up on some personal stuff. So we've been slowly working through that. And there's one outstanding item in 7626 biz that she is trying to sort out with the ISG right now. And I believe once that gets done, we'll move that forward. And because that document is normative into the BCP op, we've sort of put the BCP op sort of second. And it's basically ready to go once 7626 biz is wrapped up. So the two of them will probably slide through right together. And then on the phase two, Brian and I have talked recently, and I'm going to sit down and spend some extra spare time with Alex and Jason and Benno on helping them sort of make sure we get all the issues addressed and see about what we can do about moving forward if actually that needs to be done. So they saw an email from me yesterday. So, and then the extra over TLS draft, it's been pretty quiet. I think they've addressed most of the outstanding issues. There's a couple of items from Bob Harrell that they haven't addressed. And I'm kind of waiting to see the next version of that from the author. So that's a little slight hint to sort of get them to move along. Next slide, Eric. And I think there's one before that, but mostly there's three things on the agenda. The DNS over quick discussion with Christian, who's next. The DPRIVE early data document, which is very short. And we're very curious if there's some, we think it's useful, and we have some interesting, Brian and I have some discussions about that. And then Daniel got something to sort of entertain us at the end on signaling filtering policies. So with that, if we can bring up Christian's slides and we can get right to Christian and get things going. So thanks for being patient, folks. And like Brian said, we don't think we'll take the full 90 minutes, but we're not going to rush through anything. So thanks a lot. Christian?
Thanks, Tim. So I am going to present the draft. We have been working on the DNS over Quick. We did work on that draft off and on for the last 2 years in the Quick working group, and I just resubmitted it in the DPRIVE working group because of what we'll see next. So how do we change the slide? Good. Is that the first slide? No. No. Yes. Okay. So what I was speaking about, what we want to define is a very simple mapping of DNS over a quick connection that just does DNS and nothing else. And the principle of the mapping are straightforward. I mean, we use the quick stream to isolate connections, so isolate queries and responses. So each query opens a stream, and the response comes on the same stream, and then the stream is closed. We will have a 64K size limit on each query to be compatible with DNS over TCP. There is a specification of parallel processing, so there is no head of queue blocking. And that's also a feature of Quick, and the difference with TCP is that if there are several queries in progress and one of the packet carrying one of the queries is lost, in TCP, you will get head of queue blocking. You will have to wait until that missing packet has been corrected to process all the other packets. With Quick, you don't have to do that. The first target of the draft is the stop to recursive scenario. The main reason for that is that we cannot really address recursive to authoritative without having a way to discover the servers. I mean, if we don't have, if the recursive don't know with certainty that this server supports DNS over quick, then they are going to do a dance of trying and then failing over to DNS over UDP or DNS over TLS, and that will be just a waste of time. So the real reason to not do step to recursive in quick right now is because we are waiting for the discovery. DNS over quick operates on a dedicated port, which is to be allocated by IANA. It's not defined yet. Next slide. Thank you. So to give you an idea how it works, I mean, Quick is a fairly lightweight protocol, but still, what Quick does is embed TLS to negotiate the encryption keys of the Quick connection. So if you see a basic Quick connection, you'll see an initial packet that carries the client hello, which is the first TLS packet. Then you will see a series of UDP packets coming from the server carrying the server hello in TLS and then carrying all the TLS extensions. They will be using a basic encryption key, which is really just for verification of the packet for the initial packets that are not encrypted. And then the encryption key derived from the client hello and server hello for the handshake packets, which carries all the TLS extensions. In particular, they carry the certificates, and so we have all the properties there of TLS 1.3. Once the client receives that, it gets the what we call the 1RTT key, which are basically the data encryption key for the data session. So the client sends an handshake confirmation and then sends a 1RTT packet, which is which carries the DNS query. There is only one single arrow there because Quick has a feature called packet coalescing, and this TLS packet and the data packet are sent in the same UDP datagram. After that, well, you get the response from the server, which will carry also a bunch of ancillary TLS things like the handshake done, an indication, the session ticket, maybe an acknowledgement, and the DNS response, and you will get a 1RTT acknowledgement coming back. And the session will then be ready so that if there is another query, it can be sent immediately on the query, and it will repeat what we've seen, the query is sent, and the response is received. In fact, okay, I get feedback on Jabber that I'm not clear. I mean, I'll try to speak more slowly and see what that means. So if you see this first connection, we have a 1RTT overhead to set up the TLS connection and exchange the encryption key. And then all the DNS queries and response are basically one datagram out, one datagram response coming back, and maybe an acknowledgement after that. There are all kinds of optimization in Quick so that basically acknowledgement can be carried in data packet, etc. Next slide. Please. So one thing we specify in the draft is the handling of connection. And the handling of connection relies heavily on the fact that you can resume connection very quickly with Quick. So we don't have the same kind of penalty that we have in TCP to have to reset the connection and restart everything again. In Quick, because you have this 0RTT series, what you can do is that if the connection has been idle for some time and the recursive doesn't know whether the the server has dropped the connection or not, the recursive can simply start a new connection, and it could use ZeroRTT to send the DNS query together with the TLS request. And the server similarly could send the TLS responses and coalesce with that the DNS response. So basically what we say is that if we restart a connection, by opposition to starting the connection from zero, the response can come immediately without waiting, without additional delay. And that's very useful for connection handling, because that means that servers can have a pool of connections, but they don't have to have that pool be very large. I mean, the servers and the recursive can drop a connection of, say, something like 20 seconds, and there are very little penalty doing that because it doesn't impede, I mean, it doesn't create new delays for the connection. Next slide, please. What happened in either case when you have additional queries? I mean, additional queries can be sent at any time by the client. There is a mechanism in Quick to exercise flow control. So if the server wants to, it can limit the number of queries that the client can send on a connection and do flow control to limit that, but I'm not showing that here. And basically, I'm seeing here a client sending 2 queries in 2 separate streams, stream 4 and stream 8, and the server sending back the responses in stream 8 and stream 4. This illustrates the fact that the response don't have to be sent in order. If the response were ready at the same time, they could fly in the same UDP packet. So that was basically a set of ladder diagrams to explain how that works. Next slide, please. Now the question is, why do we want to have this DNS over Quick specification? And I show here how DNS over Quick differs from DNS over TLS and from DNS over HTTP3. The DNS over HTTP3 is effectively the same specification as DNS over HTTP2. There is no radical difference. So what works with DNS over HTTP2 will work in the same way with DNS over HTTP3 and using Quick instead of TCP and TLS. There is a lot of similarity between DNS over Quick and DNS over HTTP3. The main difference being that we don't have the HTTP3 layer. And so on one hand, for DNS over HTTP3, that gives to DNS over HTTP3 an integration with the web, but it also brings all the web implementation into the protocol, which at a minimum increase the complexity. DNS over Quick does not need the HTTP net layer and doesn't have a dependency on the HTTP platform, which makes it a more compact implementation. The advantage over DNS over TLS is that we use Quick instead of TLS and TCP, so we have all these benefits of having one RTT establishment or zero RTT work, which is very easy. We often hear discussion about whether these solutions can cross firewalls or not. Well, in truth, any of those could cross the firewalls if you mix it with encrypted SNI and or encrypted client hello that are being defined in the TLS working group. So I'm not going to delve into firewall traversal there. And pretty much the end of my presentation. Next slide, please. By now, we started working on this, as I said, a couple of years ago. And the reason we did not progress is that the quick transport was very much in flux 2 years ago. It is pretty much ready now. The spec is largely frozen. Most of the changes that we see are clarification on the specification, basically final touches. There are more than 16 interpreting implementations of the quick transport, and there are interrupt events scheduled regularly. So that means that the quick transport is now stable, and we can work on a protocol on top of quick outside of the quick working group. DNS over quick does not require changes in quick, at least in the quick transport. It defines a new implementation on top of quick. And there is no requirement on the quick working group except to have the spec as it is. There is some work to do in DPRIVE, specifically on connection management, on the details of the DNS packet mapping, things like what to do with eDNS, what to do with packet size, what to do with packet IDs. We have a specification in the draft. We'll get a better specification with the next version because we got some feedback. There is also a point about using zero RTT. As I said, zero RTT is great for performance, but we have to mitigate privacy issues and the security issues inherent with zero RTT. So we'll work on that, and we have a presentation later on zero RTT, so we'll listen to that too. But basically, my take is that at that point, the draft is in a sufficiently good shape, and the quick transport is sufficiently stable that we can start working on that in the DPRIVE working group. And my question in the next slide is, should the working group adopt that as a work item? And now I'll stop and listen for questions.
Thanks, Christian. First one in the queue is Ecker.
Hi, Eric Squirrela. Yeah, I'm sort of neutral on adopting this. I think you're making an incredibly persuasive case for why we don't just do DNS over HTTP3, but like I'm not going to lie down the road over it. I have two sort of technical comments. You said this needs its own port. I certainly see why it needs its own port as opposed to port 53, but it's not clear to me why it can't run on UDP 443 because LPM lets you demux those. Generally, I think that LPMs are a much more flexible mechanism than the port numbers. And secondly, on this question about ESNI echo and ALPN filtering, while I'm a huge fan of echo, I think it's quite probable that a large number of environments will basically ban echo, and we'll do that by suppressing the DNS queries you need to retrieve echo. So in those cases, DO3 will get the file much better than DOQ. Thank you.
Thank you, Ike. Well, what you say is correct. I mean, if we are in the business of designing the best file traversal, then a dedicated port is not what you want to do. At the same time, what you said about DNS over quick could just as well be said about DNS over TLS. It's exactly the same reasoning.
I agree.
And so, I mean, I don't think there's a new debate here. It's an issue. On one hand, using a dedicated port makes it easier for network managers to see what's happening. On the other hand, running over port 443 and running as much like HTTP as you want makes it easier to sneak out from a network that might be somewhat hostile. So yeah, I mean, there are two designs, and I would just leave it at that.
Okay. Next up, Jim Reed.
Thanks, guys. Christian, I think this is a good idea, and I support working with adoption. I'm just curious, the draft mentions that the DNS query ID must be set to 0. Could you please explain the rationale for that? It doesn't seem sensible to me. Thanks.
Well, the rationale is that you have to be clear what you are demuxing on. So if you are demuxing on the stream number, you don't want to be also demuxing on the query ID. And making the query ID 0 makes that crystal clear. Otherwise, you get an initial layer. I mean, you get an initial layer of complexity either way, but 0 appeared simpler. Now, there's the kind of stuff that we can definitely discuss in the working group and change in the draft in a later version if there is consensus in the working group otherwise.
All right, next up is Ben Schwartz.
Hi, Ben Schwartz here. To Jim's point, I'll just mention that DO does the same thing, sets the query ID to 0. I wanted to say something somewhat similar to what Ecker said, but also a little different, I think, that echo does not apply, at least as currently specified, to DNS transports, because DNS transports are the thing that you use to get your DNS queries, but echo requires you to be able to perform a DNS query before you can use it. So especially if use cases that don't have a bootstrap resolver are in scope, for example, cases where I say, okay, here's my DNS over quick server, and here's its the name that you should validate, and here's the IP address, then you should you can connect directly, but you can't do echo. Overall, my thought on this is that this all seems like it will absolutely work, and it has some very small performance advantage over DNS over HTTPS. I think for client use cases, it's not really very interesting for client recursive. I think it's potentially much more interesting for recursive to authoritative, where the performance differences might be more meaningful.
Well, yes. And it's indeed, I mean, when I was looking at that, my personal inclination was to design it for the recursive to authoritative case. But as I said, we can only do that after we have solved the discovery issues.
I'm done. I don't hear any response.
Okay, Ben, do you hear me now?
We can hear you, Christian.
Okay, so I think Ben is correct. I mean, first on the ESNI echo point, I don't want to handle the use of ESNI or firewall traversal issues in this draft. I think that belongs to deployment considerations, and they will come either way. But for the recursive case, I do agree with Ben that DNS over quick make a lot of sense for the recursive to authoritative case, because first, we don't have the firewall problems in any case. Second, it makes a lot of sense to have a lightweight protocol in that environment, if only because a lightweight protocol has a much smaller attack surface, which is a consideration. That's what motivates me most. But then we have to get experience, and it's much easier to get experience in the stub to recursive mode, because you can always configure the stub to use exactly this recursive with that protocol. So that's the reason we start with the stub. I agree with Ben, we will have to work on the recursive to authoritative scenario. Just do that later.
Okay, and Ted Hardy.
Thanks. This is Ed Hardy speaking. First, I'm strongly in favor of supporting adoption. I think that this is a very good use of Quick, and I think that it will get deployment in some of the use cases that we're currently seeing DNS over TLS or DNS over DTLS suggested, because it has the head of line blocking avoidance that Christian outlined, which I think is a very useful performance improvement over DOT or DTLS. I also agree with Christian that there is an advantage here for an eventual recursive to authoritative, especially with zero RTT, the ability to go back to an authoritative and get fresh data is clearly going to be very useful. But I think the head of line blocking problem in the stub to recursive is actually one that this will improve a good bit, simply because you'll end up in situations where you get a resource, say a web page, and you want to do all the DNS lookups in it at once. And I think Quick is a very useful way of approaching that. I understand people may want to do DOH over Quick as well. I don't think that that's something that this group needs to take up or block. It's already sort of handled by the fact that two different versions of HTTP are available. But I do think that the caching semantics are significantly simpler, in this, and I personally think that means we should take up the work and then have the discussions of things like what port numbers or et cetera in the working group.
All right, thanks, Ted and Christian. So Kim and I are going to take an action item to actually start a working group adoption call for this. So that you should see that on the mailing list in the next day or so. So please chime in on your support or objections to us taking this work on. If there are no other questions, we're going to move on to Alessandro and the early data over TLS.
Hello, can you hear me?
Yes.
Okay, good. So hello, I'm Alessandro. I'm gonna give a quick update on the using early data in DNS over TLS draft. Next slide, please. Yeah. So a quick recap first. TLS 1.3 introduced a feature called zero-RTT session resumption, which allows a client to send application data in the first round trip of the handshake, this data being called early data. It can be used by DNS over TLS clients to send DNS queries to DNS over TLS server without having to wait for the handshake to complete. And it can be useful in cases where maintaining a long-lived connection to a DNS server is not feasible. For example, on mobile clients connected to unstable network, the TLS connection to a server might need to be reestablished often. Or in the case of resolver to authoritative server, the resolver might decide to drop some connections that are maybe not used often, and then using zero-RTT, they can reduce the cost of having to reestablish the connection. Next slide. There are some caveats to the use of zero-RTT and early data, most notably the fact that early data can be intercepted by on-path attackers, and it can be replayed by said attackers to the server. So if the early data causes side effects to the TLS and DNS server, an attacker might be able to exploit this by replaying data to the server multiple times. For this reason, application protocols that want to use zero-RTT and early data need to define a policy for when it is safe to do so, and that's what this document is trying to do. Next slide, please. So the draft was originally presented at IETF 105, and it already went through a couple of rounds of discussion on the mailing list. So I'm going to present some of the changes that came out of those. Next slide. One of the main complaints from reviewers was that the language around which DNS messages should be allowed in early data and which should not be allowed was not very clear, and it could be improved. So, for example, the original draft said something like DNS updates and zone transfer messages cannot be sent over early data. The new version of the draft, however, says that only DNS messages with a query opcode are allowed, so that also removes other edge cases and other cases that were not previously considered. In addition to that, the new draft version also defines a whitelist of RR types that can be used within query messages within early data. The whitelist is defined as an IANA registry, so it can be expanded later on. However, the list is not complete. There's a lot of RR types that are currently defined, and I do not know what most of them do. So I only added a few entries to the list, but if the draft ends up being adopted, we will need to discuss which additional RR types need to be added to the list. And then there were a bunch of other editorial changes to clarify language that reviewers reported. Next slide, please. So having said that, I'm not 100% sure we actually need the RR type whitelist. And it might be that only restricting on the query opcode is enough to achieve the goal here, which is only allow DNS messages that are idempotent. Again, I don't know what a lot of the RR types defined do, so this might use some input from people with more DNS experience. And then if we decide that the list needs to remain, we will need to discuss which RR types to add. Next slide. So I guess the question now is whether the working group is interested in this work and whether it should be adopted. Any questions?
All right, it looks like we have a run on Ben's here. So first in the queue is Ben Force.
Hi, I support adoption, and I don't think we need a list.
Okay, and Ben must be invoked thrice, Kadek.
This is Ben Kadek. I had a couple points. One is that I think that having the explicit whitelist is basically what we had in mind when we were writing 8446. I know Hacker's on the call, so he can disagree if he wants to. But I think that it's reasonable to have the whitelist both for the query opcode and the specific RR types, even if we end up allowing most of the RR types. And then my second point was regarding the description of the 0RTT data requests as needing to be idempotent. I think it's actually a little bit stronger of a condition than that, because idempotent we usually think of as just sort of relating to the same query being reordered or reapplied with itself. But I think we actually need a stronger criterion that the query has the same results and the same side effect when reordered with other queries that might be happening or other events that might be happening on the server, which doesn't necessarily seem like a problem off the top of my head, but I just wanted to point out that it is a stronger condition we have to consider.
Okay, yeah, that makes sense. I'm not quite sure what the language in the draft is right now. So if it needs to be clarified, I'm happy to do that.
I think it does need to be clarified a little bit.
Okay.
And a question from Christian.
Yes, well, it's an interesting draft, but I think that it misses one of the points that DKG has been making about replaying of 0RTT. The problem of replaying 0RTT is that if a client sends a request in 0RTT, an adversary can copy that and repeat it later and look at the side effects of that request at the server. For example, does the request triggers a query from the server to a specific name server on the other side? And I am not sure, I didn't see that in Alessandro's presentation. I didn't see this issue of side effects and how side effects can be privacy leaks. I think that should be discussed. And the best way would be to go to DKG's original analysis and incorporate it in the draft. Apart from that, yes, I do support adoption because that's what I suggested is exactly the kind of thing that we should do in the working group after adoption.
Right. So to the point of DKG's analysis, the draft already includes some security considerations around at least one specific attack that was identified in a discussion from, I think, was a year ago or a couple years ago, from the discussion with the DKG. And it might be that we also need to add something around, for example, caching. But yeah, I'm happy to add some language there or accept PRs to add that.
Thanks, Alessandro. Much like the first draft, Tim and I are going to craft a call for adoption, and we encourage everyone to voice their opinion of support or disagreement with taking on this kind of work. So right before we move on to our third presentation from Daniel, I just want to encourage everybody who's not signed a blue sheet to go to the Etherpad and sign the blue sheet. So next is going to be Daniel.
Hi, can you hear me?
We can hear you.
Okay, good. So this presentation is going to be about signaling resolvers of filtering policies. So next slide. So the motivation for these mechanisms is that currently filtering policies implemented by the resolver seems an important things to know in order to proceed to a potential selection of a resolver. And currently filtering is clearly associated to parental control, and it's being performed through a canary domain. And so the main motivation for this presentation and document is to have a standard mechanism so that we can have an explicit announcement from a resolver to a client to say, these are the filtering policy I'm implementing, as well as a standardized mechanism for a client to request a resolver, which are the filtering policies enforced. Next slide. So, because either the resolver should be able to inform the DNS client, and the DNS client should be able to request a resolver, we get two kind of different mechanisms. So one that's where the resolver can inform the DNS client, and another one when the DNS client, in relation with the resolver, can request, which are the filtering policy put in place. Next slide. So communications between a DNS client and a resolver have already some history. And in our case, we are largely inspired by the communication of a trust anchor. So it's somehow different. So we're using eDNS0 as well as a specific DNS query. Next slide. So how do we represent the filtering policies? So in this case, we represent them through a datagram that we designated as data, and the resolver is advertising the filtering policy by carrying this data through an eDNS0 record. And when the client is willing to request to that resolver, this data is going to be carried through, going to be associated to a special FQDN. Next slide. So here is basically how the data is built. So we basically define some filtering categories, and the full filtering policies is an aggregation of those filtering policies, which assumes that in this case it's an addition of all of those. I mean the names. So the names of the filtering policies are not, I mean, have to be standard defined through the INA. Only provided some examples. Of course, we can increase those, but the idea is to remain quite simple and not to have billions of combinations. Next slide. So when you advertise those, I mean, this data is being carried through eDNS0 options. Next slide. And when the DNS resolver wants to actually check which policies are being enforced by the resolver, so he sends a specific request. So what is important is that Q type is set to null, and the filtering policy and the Q name is set to _filtering policies.example.com, where example.com is the domain name, so the FQDN of the resolver. So in some cases, the application may only know the IP address, in which case a reverse resolution might be needed to derive the domain. Next slide. So, I mean, there are some point of discussions probably. So, I mean, that's worth being mentioned. eDNS0 is not protected via DNS sec, so might be considered. So when the server is advertising the filtering policies, in this case, using these mechanisms, we would not be able to protect that using DNSSEC. While when the client is requesting that, I mean, the DNSSEC can be used. And there is also the case of when I have a resolver that is depending on different upstream resolvers. So probably all these filtering policies should be aggregated and provided to the DNS client. Other things is that such mechanisms might assume that we have one policy per FQDN, so per resolver, which is a little bit different from a situation where different policies are made available by one resolver to a DNS client. So this is one aspect of it. And maybe another consideration is that whether we should support different characteristics of the filtering policies, or should we only advertise we are filtering. It's a binary Boolean values, truth or not. So, well, I leave the floor open to any suggestions and comment.
It looks like we got a couple of questions. First up is Alex.
Thanks for the presentation. I think it's actually an interesting idea. I see actually two problems with that. One thing is with the table of the possible filtering descriptions. I mean, illegal caused me to cringe a little bit because illegal depends on the jurisdiction. Is that the jurisdiction of the server? Is that the jurisdiction of the client? So there's all kind of complications to that very table. So I think that table is really opening the can of worms. I don't have a suggestion how to improve that though. So I think the question is also, do we want to have a really specific indication of what each category means, or do we have like a rough indication of what categories the name server is attacking? And the second one is, I don't really like the solution with the queue name of using the domain name of the resolver. So I don't have a solution to that at the moment, but I don't think it's very elegant, particularly because of the reverse resolving of the resolver name. And then you need to identify what is actually the domain name of the resolver. Do we want to apply the public suffix list to that name after we have reverse looked it up, and so on and so forth. So these are the two things that I think we need more work on.
Okay, so well, thank you for the suggestion. Yeah, so I agree with you that if we have to define some categories, we might go into unnecessary debates. So yeah, so this is actually something I'd like to know whether people are more in favor of having some of those categories or none of those. We may simply add filtering is present. I'm fine either ways. Yeah, so that's it's something that needs to be discussed and agreed. I don't have a strong feeling going into one or the other directions either. Also, regarding the other one, having a special domain name. So what I came to also is if only the problem is due to the reverse resolution. We could also agree maybe on a very special name, like we have unspecified name like home.harpa that are not valid outside the home network. So we could have maybe similar names that won't be valid outside the end resolver. So maybe we can come with those things. But so what I don't know is that the problem due to the reverse resolution, or you don't want this to be addressed through a DNS exchange?
Quick response. No, I think it's okay to address this through a DNS exchange, the filtering policies itself. But I think that the discovery of the domain of the resolver is a step that's not necessary anywhere else. So if we can come up with some alt name or whatever,
Okay.
then that would be preferred, because I think it needs to be, the client needs to do this once just because to discover the filtering policy. So it would be much easier if we could agree on like an IANA registered name for that. And that opens up another can of worms, but that's a different story.
Okay. Yeah. Okay. So I see your point. Another thing that was also being mentioned is that if we have a service, a resolver discovery protocol, it's also something you could learn this way. For example, if we're using SVCB records, you could have that as an a key parameter, a key value that specified those data also. So that's another way to discover that, which is complementary to the mechanism described here, I think. So thank you. Maybe we can go next unless you have something to add. Thank you.
All right, next in the queue is Eric Mascorla.
Hi, Daniel. So I guess my question is, do you know of anyone who wants to consume this information in this form? Do you know of any client which wants to consume this information?
So one of those clients could be the client using the canary domain.
Yeah.
And so
yeah, I guess my question is, have you talked to anybody who's doing one of the canary domains and wants to do this? So
the people I talked to were the people setting the canary domains.
I understand, but that the relevant question is who would wish, like, is the people who are looking at the canary domain want to look at it this way?
Yeah, that's so. That's why I'm waiting for your comment.
Oh, okay. Yeah. So I mean, so it seems to me that there are two things that make this proposal not like super awesome for me. The first is that having it stuffed in like EDNS 0 means that I have to go figure out whether like the operating system resolver will let me get this information. And the nice thing with the canary domain or something like it is that I can like guarantee do it with like the queries that I can actually make out of the operating system resolver for basically any operating system. And that's like a pretty hard requirement because otherwise if I'm my own resolver. So pretty much it has to be the case that if you can't like get this information by doing like get adder or some other thing that every operating system has, it's like kind of a non-starter for me. The second is that this sort of detailed information about what kind of filtering policy seems to create like a lot of confusion and ambiguity that doesn't actually help me very much because the only thing I'm really interested in, is there policy enforcement on this resolver or not? Because like it's just too hard to explain to the user. Well, here is like some like kind of ambiguous setup for policies which you have to like you know, which somehow maybe you want this, maybe you don't.
Okay, so let me rephrase that. So I mean I heard some cut during the response. So you don't think having filtering policies is a good thing? It's more confusing than anything else.
Yeah, I just don't know what I'm going to tell the user. Like, I mean, okay. I mean, bear in mind that like what Firefox does now when it sees the canary domain is just silently disables Do. You know, we've talked about having it be like, you know, we've been told to disable Do because we disable like flagging it to the user, but like I just don't think we flagged to the user. It's been flagged because of like these 3 different filtering policies which ostensibly your network enforces.
Okay, so that's fine. And the other point is that EDNS 0 is that, I mean, you don't like because of middlebugs that could strip the EDNS 0?
No. Will the operating system resolver interface let me get it?
Okay.
Like basically understand that like Firefox does not have its own DO53 resolver. It just uses the you know, the operating system resolver. I think Chrome has its own DO53 resolver, but not everybody does. And so in that case, you want it to be able to be something you can do an operating system call rather than be something you can't. And I don't think, and my impression is this data is not available to me on every operating system, or in fact, maybe any operating system.
Okay, right. So yeah, if at least on one operating system, if you can't have access to data information, it's I mean you won't be able to use that. So
that's correct.
In which case, I mean, so would you suggest that we only focus on a client requesting and not the EDNS options?
Yeah, and I think, as I said,
I think those that can have access to.
Right. I think I guess I would want to do one thing, not several, and And so I'm going to want to do things, as I say, that I can get via existing operating system APIs.
So basically limit the scope to only having this DNS exchange, not with the option.
As I say, the requirement is that it has to work with like GetAdder, the existing OS APIs. That's the underlying requirement.
Okay. Okay, thank you. Yeah, I'm fine to implement. To update the document with your inputs. Well, yeah, we'll need. So, yeah, I'm fine with that. I mean, it makes sense to me.
Okay, next in the queue is Chris Box.
Hello, yeah, it's Chris. So I can see that the idea of learning filtering policies is useful. So right now we have Cloudflare offering specific IP addresses for different filtering sets. So 1112 for malware, 1113 for the combination of malware with parental filtering. So when I walk into a hotel and connect to the Wi-Fi, it may be useful to learn what's happening in that resolver. So my question is, could you clarify how you see this relating to ADD? Because I think you said it was complementary. And to my mind, ADD is charged with solving the problem of how you discover which resolvers are available and selecting from them. And as part of the selection process, you might want to learn these filtering policies. So how do you see that sitting?
So, yeah, it's a good question. I think at that point, so I mean, the same information could be disclosed through a specific discovery protocol. But it might not be available through that way. And so if you're connected to one server, you want to know whether this, I mean, it's a different way to discover that, I would tend to say. But I mean, suppose we have a lot of different things to discover. We won't be able to add all those keys to SVCB record, for example. So if you're connected to one resolver and you want maybe specifically know whether he's implementing some filtering, if this resolver is not implementing the service discovery, the resolver discovery protocol, so that's this is why I would mention that as complementary.
Okay, thank you.
All right, next in the queue is Vittorio.
Okay. Well, personally, I think I'd find something like this useful, but I agree with Iker. I mean, in the end, this is useful only if there are clients that want to implement it. So I think that's the first thing we should understand. And same for the level of detail in discovering the policy. But I think that if you want to be detailed, it will need to be more nuanced than what you have now. But then too complex for, I mean, basically being useful. So perhaps this should be done in two steps. So first, maybe we should agree on the functional requirements. So which kind of information we need to communicate, and then start by shedding on how do you fit this data into a DNS communication. And finally, I mean, I also had this issue about where does this fit better, if it's more like ADD draft. I mean, I know that there's another draft there that already does something like this, I think. And this looks more like, I mean, fitting the second point in the ADD chart. So I don't have any strong view. I'm fine with whatever, but at least we should make sure that all the work related to these kind of things goes into a specific working group.
Okay, so yeah, so I mean, depending so well, given all the feedback, I think everyone agrees that we should not have a detailed filtering policy. So that's my first conclusion of all the things I received. And I'm fine with that. Now, related to the relations between ADD, if this work could have been hosted in ADD, I agree it could have been hosted. On my point of view, it could have been hosted, but we discussed with the chair, and the ADD chair said DPRIVE is more appropriate for that. So that's what the reason is in DPRIVE. Now, anything I was mentioning, could it be discovered through a discovery protocol provided in ADD? My answer is yes. We can still have a SVC key parameters saying filtering true or not, and that could be advertised. But so it's a different way to advertise a parameter outside a service discovery protocol. So yeah, that's what I meant. And yeah, so I don't think it's conflictual at that point. But it's yeah, we should not have overlaps, or if we think it's conflictual.
Okay, next is Schwartz.
Hi, this is Ben Schwartz. So yeah, I agree with some previous commenters that this kind of work should not be in DPRIVE. This is not a privacy enhancement for DNS. It also clearly overlaps with some work that's ongoing in ADD. And you know, if it wasn't included there, then maybe that reflects a lack of space in ADD for additional work, and maybe this needs to be combined with the existing proposals on this topic. Another reason that I think we need to be combining it is because I do not want us to end up with a separate discovery mechanism for every aspect of metadata about the user's resolver or resolution path. We need a unified metadata scheme. So we can't invent information discovery mechanisms for each piece of information we'd like to learn. We need a general information discovery mechanism. And lastly, on the particular kind of information that is proposed to be discovered here, I want to point out that, in my view, this is an evil bit, which is to say that it is a claim made by one party in the protocol that the other party is somehow being expected to use but cannot verify. And that actually makes it very different from the canary domain, where the thing that the client checks is it measures a behavior of its resolver, and so in effect it verifies the property that it is attempting to measure.
So the first comment, whether it should be only, well, I understand that the first comment is that we should not have a specific discovery mechanisms outside the resolver discovery mechanisms. So I don't know if it's a valid comment. If people agree this way, I'm fine with that. It's not obvious that everyone is going to configure and to adhere to the discovery mechanisms also. So that's the thing I'd like to nuance, and this is something that could be immediately actionable. It could, I mean, and we have all the things like if you want to know which case is being used by the resolver, is that something that should be discovered by the DNS client, or should it be advertised to generate resolver discovery protocol? So I'm not sure that I do somehow share your point, but I'm not sure it's we can have a single mechanism for everything. So That's the thing,
In case I wasn't clear, this is Ben Schwartz. I just want to clarify that I'm not saying that this all needs to be rolled into the mechanism by which you learn of the existence of a resolver, but rather that
Okay.
all of the metadata about a resolver that you might want to know should be discovered through a single mechanism, otherwise, or at least a unified framework. Otherwise, we end up with a novel metadata discovery mechanism for every piece of metadata that we intend to learn.
Okay, so just to clarify, you would like underscore metadata so that we got all of those data instead of having underscore metadata 1, underscore metadata 2, and so on.
Yeah, so in particular, the DNS op working group already has an adopted draft called the Resolver Info RR type, Res Info, which proposes a unified framework for learning metadata about a resolver. I don't know that that draft is the final perfect answer to this problem, but that's the architecture that I think we should be aiming for.
Yeah. Okay. Yeah. Yeah. Correct. If you could point this exact draft, it would be helpful. But this is also something I thought that if we define something, it could be extended to. It should not be only about filtering services, but could be extended to other future functionalities. So I agree with that. Now, I think you mentioned that you wanted this to be part of ADD instead of this deprived. I mean, to me, I don't care which working group it is. It has been decided. It has been deprived. I mean, it was mostly the ADD chairs that preferred this to be hosted by DPRIVE. So, I mean, for me, I'm equal regarding the wherever it's being hosted.
Okay.
And this is Eric Vink here, the responsible AD for the group. I also believe that this document is not really fitting the DPRIVE charter.
Yeah, I it's I can but so well the thing is what I'd like to clarify is I'm fine sending that to ADD, but I mean do we think it has no places, no working group, or do we think ADD is the right place?
So Daniel, I think the right answer here is I think first of all to go off and maybe take a look at what that DNS op resolver info draft says and whether or not you could actually incorporate the information that you have in your document into that framework. And then I think once that is figured out, then we can talk between the work group chairs and the area directors to see where it actually makes sense to do the work.
Okay.
Thanks, Brian. Brian, this is Barry Leba, responsible AD for ADD. Remember, the ADD has a very tightly scoped charter right now, and I've asked the chairs to be very selective about what they accept, to start off small. It may be, Daniel, that what you're proposing makes sense to go into ADD later, and it may just make sense that right now we need to hold off. But Brian's suggestion is the way to approach it right now.
And Daniel, this is Tim. I put the link to the Resolver info draft in the WebEx chat, and I agree with one thing Ben said that I think we really need to take forward is we need a common framework, a unified metadata framework. And I think that, a lot of the drafts that I see like this are very interesting, but they all have their own way of sort of solving the same problem. And I think Puneet and Paul have a draft that, if you take a look at it, hopefully can fit, what you're doing, or maybe it can be extended, right? The whole goal of that one is to make something you can put your own metadata into. So
Yeah, that would be even better.
totally encourage everybody to take a look at that.
Yeah.
Thanks.
Thank you.
All right, so let's move on through the queue. Eric Klein is next. Did we lose Eric? All right, we'll see if he can circle back around. Next up is Benno.
Hi, query from the Jabber room. Question. So one of the questions was already answered in the previous discussion. So one still open is why do you use, or can you use also a bit mask instead of a single number for the filtering policies? It's more the implementation question.
Yeah. So, well, if we remove the filtering policies, we don't have to think otherwise how to do that. But yeah, I agree. It could have been implemented with a bit mask.
Thanks.
And next on the list is Jim Reed.
Guys, I'd like to agree with the points that Ben did a few minutes ago. And I'd like to go back to one of the points that Eric made, because I think that's also very well made. And my question to you, Daniel, is why did you choose to go for an EDNS option rather than a dedicated resource record type? Would that not be a better option all round, assuming this thing was to go forward? And maybe that resource record type might be the best info thing.
So the question to why did I use the EDNet 0? It's well, it was mostly because I saw that a lot of information were provided through EDNet 0 option. It's not that I was not open to any other things. I thought that, I mean, we had already experience in that field, so I wanted to benefit from this experience. But I'm happy to take other means more appropriate.
Thanks.
Okay, so I think that's it for this queue. Oh, is Eric back?
Perhaps. Does this work?
Now it does.
Okay, thank you. I apologize. It seems like WebEx told me I was unmuted, but then it also did not tell me that I could not find a mic. So I was both unmuted and micless. I think most of the things I wanted to say, others said more eloquently. I just wanted to also note that I'm a little skeptical of the ultimate usefulness of some of all of this, because I think we could easily end up in a lot of different scenarios, one of which is where all resolvers announce that they do filtering, because all resolvers and all clients are in some jurisdiction somewhere. And just by virtue of being in a jurisdiction, all governments may have, we may end up in a world where there are just a legal minefield of policies. And so it's not clear to me that there could be a useful signal at the end of all of this. That was all. Sorry. Also, things like, if somebody passes a law about their filtering policies apply to their citizens wherever they travel throughout the world, then you need to know the citizenship of the person who's making the query or who owns the device. I have some skepticism in this area. Thanks.
So I do understand. There are two things. Some filter. I mean, and it really depends what we want to advertise or the meaning of that bit or maybe value we want to advertise. But it's true that legal enforcement force you to implement some kind of filtering, and those depends to the jurisdictions the resolver is. But it's not the same type of filtering that we expect for when we subscribe to a filtering mechanisms based on anti-malware detection or filtering adult content. So yeah, so we have to be clear.
It's the voluntary filtering that the resolver is doing on its own, not as mandated. Okay, so the illegal bit also, I guess, doesn't make sense then.
Yeah.
By definition, that's
one
you're
bit.
saying, but the illegal bit is implied at all times.
So
Actually,
it's yeah, it really depends what you. I mean, what I meant by illegal is content that are not that are illegal but in nature directions. But I mean, the words behind I mean, I mostly wanted to express some different ways to do filtering, and whether it might be useful to have those different categories. But my understanding is that it's not useful to go into the details. So having a single bit saying we do filtering, and in which case it's going to be filtering being performed by the resolver in addition to what is jurisdiction is asking to do.
understood. Thanks.
Thank you.
All right, thank you, Daniel. I think that wraps everything up for this session. So even though I said I thought we were going to end early, we are basically ending on time. The two call for adoptions are out on the mailing list. One for the DNS over Quick and one for the early data draft. So please voice your opinions there on those two calls. One final reminder for everyone to go sign the blue sheet. The link is both in the Java room and in the WebEx chat. So without that, I think I want to wrap everything up. Thanks to everybody for joining us, and we will see you soon, hopefully.
Thank you. Bye.
Thank you. Yep.
All right.